Good afternoon, everyone. Hello, JNV Krishna. So we are live now. Uh, how are you? In the previous class, if you remember, we were discussing about Bernoulli's applications of or the uses of Bernoulli's theorem. And in that sequence, we were discussing, if to be precise, we were discussing about velocity of efflux and the Torricelli's law. That's what we have discussed till now. So today we will continue our session from that part only. So I think it's already 3:50. We should start now and wait for 1 or 2 minutes so that few more students may join. Very good afternoon. Okay, so let's start. Wait for 1 minute so that the students can join. Okay, we should start now. Okay, so what we have discussed, if you go back to the previous slides, what we have discussed, we have is discussed that this is the range of a velocity of efflux. When a orifice is made in a tank or in a container filled with the liquid, then liquid comes out of the orifice with a velocity root 2gh, and the range of the liquid that is falling on the ground is this one. So now what I'm saying that if I make the holes at different parts like this one, if I make the holes at different parts, then liquid will fall at different places, so range will be different. So my first thing is, at which point or at which depth should I make an orifice so that liquid falls at maximum distance? That's what I'm trying to identify. So what we have assumed this height or this depth as h, this one, and the total height of the container was h. That's what we have assumed. And what we have calculated that range, that is range r, is equals to 2 root of h minus h. That's what we have calculated in the previous session. So what is this r? R is the range of the liquid which is falling on the ground. So we need to identify at which height should the orifice be made so that liquid falls at the maximum distance. So this h is to be identified for maximum range. That's what our task is. So what if I say r will be maximum if r square is maximum? Can you relate this thing? If r square is maximum, then r is also maximum because we are just squaring these things. So if I square it, so r square will become, if I square this out, it will become 4 h minus h. This is what it is. For maxima and minima, you have studied that in, I think, maths or or in the math that is described in the physics, that initial stage is calculus. So what you have studied, if I differentiate it, this range R depends on the small h. So if I differentiate this R square with respect to small h, we will get the maximum. We will get the maxima or minima, condition for maxima and minima. So what is it? If I differentiate it with respect to the variable h, differentiate what? R square. And if it comes out to be zero, so this is the condition of maxima and minima. So differentiating it, what you will get, 4 is a constant, 4 is a constant taken out. H into H is what? Capital H minus H square is what? 2H. You know the differentiation, I think, is equals to 0. So what it will be? H minus 2H is equals to 0. So H is equals to H by 2. Now, I don't think that you know about the differentiation thing much, but let's don't go with that. Don't go with that differentiation part if you don't know. If you have studied differentiation, then it's completely okay. If you don't know how to differentiate things, just don't worry. Just remember the result. What does this result signify? That when the orifice is made at the mid of the container, then the range of the liquid is maximum. Then the range of the liquid is maximum. For example, if a container is filled up to a height of 10 meter, then where should I make a hole so that liquid falls at the maximum distance? Then you will say at the half of the distance. At the half of the distance means at 5 meter depth. You should make a hole so that liquid will fall at the maximum distance. Is that clear? So you need to remember this thing, that orifice should be made at half of the container or half of the height of the container for the maximum range. That's the one thing. Another thing. Now, what is the maximum range? What we have calculated, the position of orifice. Now the question is, what will be the value of maximum range? What will be the value of maximum range? So we are going to calculate the value of maximum range. Okay. What we are going to calculate? Value of R max. These things straight questions comes from this part. So what is R max? So for before going to with the R max, you first need to write what is R. R is equals to 2 root of small h capital H minus h. This is what h. This is small h. This is capital H. Capital H is the total height of the liquid. Small h is the depth of the orifice. Okay. So for R max, what we have learned, for R max or maximum range, what should be the value of small h? And we have seen that h should be h by 2. Place this value. If you place this value, you will get R max is equals to 2 root of h by 2. Small h is replaced by h by 2. Bracket h minus, sorry. You can see that h by 2 into this will also be h by 2. You can see this 2 and 2 will come out as a 2. So it will be cancelled and h square will be h. So R max is equals to h. So what is the maximum range? Maximum range is what? Equals to the total height of the liquid filled in the container. These are the two very important things. Try to remember these two things. Try to remember all the formulas. So, what are the three important terms we have learned? Velocity of efflux, root 2gh. That was the velocity of efflux. The direction of this velocity is horizontal. Another thing. Second thing. Next thing, the range of the liquid is, you will say, 2 root h, h minus h. For R max, h should be h by 2. This is the third thing or next thing. Another thing is, what is the maximum range? That is equals to h. So remember all these things in mind, and there is a question on your next slide. Try to solve it out within the time limit. There is a question on your screen. You have 1 minute of time. If you can solve it, that's very simple question, very basic fundamental question. Try to solve it. I am not going to speak anything for the next 1 minute. Okay. I am giving you the option. So just comment the answer. So there are two questions asked. Calculate initial speed with which water flows from the orifice. First question. Also calculate the speed with which water strikes the ground. So there are two questions. So I am giving two options. First option is 10. Both are the speeds. So the speed is in meter per second. So I'm not writing the unit. 10 and 10. First option. Option B is 10, 20. All units are meter per second. Option C is 10 root 2, 10. And option D is 10, 10 root 2. All units are in meter per second. You need to select the right answer, right option. First part and second part. These are the two answers of the question. These are again the two answers, two answers, two answers. You need to pick one option. Comment quickly if you can solve it. Anyone from YouTube? Anyone from Zoom? This is a simple question. You can actually answer. Okay. So let me solve the question. Okay, have a look at that. Let's suppose what question says, let's suppose water is filled up to a height 5 meter. Let's suppose this height is h1 and the height of the table is h2. Clear? That's the one thing. Now, what is asked, that orifice is made at the bottom, near the bottom of the container. So, what we have learned, velocity of efflux V is equals to root 2gh, where h is the depth of the orifice from the surface of the liquid. And from the surface, this is the surface of the liquid, and the depth of the orifice is h1. I am writing it h1. Now place the values. If I change the color of the pen, you will see that V is equals to root 2, G is 10, and what is height H1 is 5 meter. What it will be 50 into 200, that is root of 100. So V is equals to 10 meter per second. This is the velocity of the liquid coming out of the orifice. First part is sorted. Now what is the second part says? The second part says also calculate the speed with which water strikes the ground. So now remember one thing. Let's suppose this is the water coming out of the orifice. Its initial velocity is what? 10 meter per second. That's what we have calculated. And it is this velocity is in the horizontal direction. And this velocity, this liquid is going down, 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 and you were asked about this velocity. This velocity. Let this velocity is V reaching the ground. I have assumed it as Vg. Clear? Now, you need to calculate this velocity. First thing that you can see here that this velocity will have two components, one in the x direction, one in the y direction. You need to calculate both of these components to find the velocity at the ground. Now, have a look at that. When this liquid starts falling, it starts coming out of the orifice, what you can see, there is no acceleration in the horizontal direction. So velocity in the x direction will remain constant. Velocity in the x direction will remain constant. So I will write velocity in the x direction is constant, and that constant value is what? 10 meter per second. That's the one thing. Initially, when liquid comes out of the orifice, it has only horizontal velocity 10 meter per second. It has no vertical velocity. After some time, at the point of ground, at the time of reaching the ground, what it has, it may have gained some vertical velocity that can be calculated using kinematic equations. And that velocity is what? Again, root 2g h2. From where this formula came? This formula came from the kinematics third equation, v square equals to u square plus 2gh. U square plus 2gh. So if you solve it out again, velocity in the y direction is 2 into 10. And what is the height? This one is again 5. So velocity in the y direction is again 10 meter per second. So we have calculated horizontal velocity, we have calculated vertical velocity. So velocity at the ground is under root Vx square plus Vy square. That's how it is calculated. Vx square plus Vy square under root a square, parallelogram of rule of vector addition, under root a square plus b square plus 2ab cos theta. So if you solve it out, it will be 10 root 2 meter per second. So what are the two answers? First answer is 10 meter per second, and second answer is 10 root 2 meter per second. And both these answers, if I see, then option 4 is correct. Option D is correct answer. N and 10 root 2 meter per second. I think it is clear. Now moving further for the next concept. Now our next concept is surface tension. This is again a very important concept. If you can see, you have seen a lot of phenomena related to the surface tension. This is a very common phenomena. You can see very often, but I don't think you can recognize it. So I will show you some examples so that you can recognize them. What are those phenomena? Have a look at that. What you can see here. there is a glass of water, or there is a beaker which is filled with water, some liquid which is looking like water. In fact, it is water. And there is a paper clip. If I can see, there is a paper clip which is just swimming at the top of the liquid surface. So generally, they such kind of stuffs sink and in the liquid. But this paper clip is gently placed there, and it's just like that. It's just not sinking. So there might be a force which is holding this spin. And you can see one more example here. I will explain all these things to you. You can, first of all, let's see some examples. What you can see here, there are few mosquitoes type of insect or mosquito, you can say. They are just swimming over the water. You can see it very often, like uh, wherever there is a water filled, the mosquitoes sits over there and just enjoy the swimming there. Mosquitoes, spiders, all such things, all such insects can flow over the liquid without doing swimming kind of thing. They just sit over there. So this is due to the surface tension of the liquid. One more example, you can see that the drops of the liquid are always spherical. This is also due to the surface tension. This is also due to the surface tension. Now, before going further, before defining the definition of the surface tension, let me describe a few things to you. Let me describe a few things to you. First of all, liquid behaves differently. Let me explain first. For example, there is a container in which liquid is filled up to this height. Liquid is filled. Now, what I can see, or what I will tell you, that the top portion of the liquid, the top portion of the liquid, like this portion. So this portion of the liquid, this portion of the liquid, this distance is of the order of molecular distance, of the order of molecular distance. Molecular distance, you know, some angstrom. So it is of the order of few angstroms. So this distance or this thickness of the liquid is called surface, is called liquid surface. And the portion below it is known as bulk liquid, is known as bulk liquid. So the behavior of these two portions of the liquid are different. Bulk of the liquid behaves differently, and the surface of the liquid behaves differently. First thing that you should keep in mind, all the phenomena, the pressure thing, the Bernoulli's theorem, all such things we have learned for the bulk of the liquid. Now, the surface of the liquid behaves differently. And one of the property of the surface is surface tension. One of the property of surface is surface tension. So what is surface tension? Surface tension is the property. Listen to me very carefully. I will give you a written definition of that as well. So first of all, you have seen the phenomena associated with surface tension. What is surface tension? Surface tension is a property. Property of what? Property of liquid surface. One thing is clear, this is a property of liquid surface. What it does, which tries to minimize the surface area, which tries to minimize the surface area, is called surface tension. I think definition is clear. Definition is on your screen. What is the property of liquid surface due to which it tries to minimize its surface area is called surface tension. Is called surface tension. So surface tension एक property है किसकी प्रॉपर्टी है? लिक्विड की सरफेस की, जिसकी वजह से वो अपना एरिया मिनिमाइज करने की कोशिश करती है। क्यों मिनिमाइज करने की कोशिश करती है, कैसे मिनिमाइज करने की कोशिश करती है, हाउ इट, व्हाई इट ट्राइज टू मिनिमाइज, वी विल लर्न इट इन द लेटर सेक्शन. We will learn it in the later section. I will explain it, all the concept related to it. But first of all, just try to remember this thing. Clear? So if it tries to minimize its surface area, then I can give you an analogy. Just take a balloon. Take a balloon. कोई balloon है, and cut it out and take some portion of the balloon's rubber. Balloon has a rubber kind of property. Na? Take some portion of the balloon's rubber and stretch it in all the directions. Stretch it in all the directions. So the surface of that balloon, which is stretched in all the direction, that's how a liquid surface behaves. That's how a liquid surface behaves. Can you imagine the thing that I have told you right now? What I have told you, that take a balloon, cut it out, and make a portion of that rubber, stretch it out in all the directions, then this surface is exactly same as the liquid surface, which tries to, if you stretch the balloon's surface or balloon's rubber, then it will try to bring in closer. It will try to shrink. So that's how the property of the liquid surface is. It also tries to shrink. Is that clear? Now, I will show you what is the magnitude of surface tension, how is it calculated. For that, just have a look at that. Let's suppose this is the surface of the liquid. I'm not going about the bulk of the portion. This is the surface of the liquid. Let's suppose I have divided this surface in two parts like this. Clear? So if you can see that this is a stretched rubber, this is a stretched rubber surface, stretched rubber surface. Then what you can see, like this is part one and this is part two. We have divided it in two equal parts. This line is imaginary line and we have divided it in two equal parts. Now, what I say, this first part, can you imagine, will try to attract the or try to pull the second part. It will try to pull the second part like this way. And the second part will try to pull the first part. And during this process, they will exert some force F. They will exert some force F. So surface tension is defined as, due to this force, some tension is created, and that surface tension is defined as, it is denoted by T, and it is defined as T is equals to this force of pull per unit length, where L is the length of this imaginary line. L is the length of this imaginary line. So what we have learned, that surface tension is defined as force per unit length. From this relation, you can identify the unit of surface tension is what? Newton per meter. Another thing. Now keep everything in your mind. Whatever I am telling you, this force, this force is tangential to the surface. This force is tangential to the surface. Always. This force is always tangential to the surface. Another thing, Another thing that you can see, if I calculate the value of force from this relation, then value of force is T into L. T into L. This is what? Force of surface tension. This force is what? Force of surface tension, or the force exerted by one part of the surface on the other part. Force exerted by one part of the surface on the other part. Clear? Or the force with which the surface pulls the other part of the surface. This is that force. And this force is always tangential to the surface. I think all the things are clear. Now, moving further. One more thing, it is a scalar quantity. Scalar quantity unit is Newton per meter. Everything is there. Now, moving further. There is a concept test, a very simple question on your screen. You have 1 minute of time. Water is kept in a beaker of radius 5 centimeter. Okay, try to solve it out. You have 1 minute of time. Okay, let's read the question. Question says, water is kept in a beaker of radius 5 centimeter. Okay, so let's draw a rough diagram. This is a beaker in which water is filled like this. The surface of the water will look like that, now. Now they are saying consider a diameter of the beaker on the surface of the water. Now consider a diameter. So if I consider a diameter like this, find the force by which the surface on one side of the diameter pulls the surface on the other side. So that's what I have told you, that the surface, the force with which its part of surface pulls is F is equals to T into L. F is equals to T into L. L is the length of the imaginary line. And that length of imaginary line is what? Is this the diameter? Radius is 5 centimeters, so diameter will be 10 centimeter. Okay, so this is very simple question. F is equals to T is what? They have given surface tension of water is 0.075. So I will place the value 0.075 into length is what? 2r. Length is what? Diameter. Diameter is what? 10 centimeter into 10 into 10 raised to the power minus 2. Centimeter is converted into meter. So force is what? 0. I think this will be 10 power minus 1. 0.075 Newton. Or you can write it as 7.5 into 10 raised to the power 123 minus 3 Newton. This is a very fundamental basic question. There is no need to worry. Simple formula based question. I think it's clear. This is the force by which one part is pulling the other part. Next question on your screen. This is a very good question, important question. Now, first thing on your question is a thin liquid film. Thin liquid film. So what is this film? Okay. You have seen many a times that if you dip a wire, this wire or a loop, if you dip a loop, then in a soap solution, then a transparent kind of or a simple kind of layer is seen on the loop, and that layer and that very thin layer is known as film. Is known as film. We called it as a film, transparent film. It is sometimes seen colored, so that's why I have drawn it colored. Okay. So now, what is it saying? It supports a weight of 1.5 into 10 power minus 2 Newton. That means there is a weight on the slider. This is sliding wire, and this weight is supported by this wire. Okay. Find the surface tension of the film. Very simple question. Now, listen to me very carefully. One thing, every surface tries to minimize its area. That's what the property of surface tension is. Every surface tries to minimize its surface area. So that is the property of surface tension. So this liquid film will try to pull this slider up. So it will exert a force in the upward direction. It will exert a force in the upward direction. And the question says supports a weight. That means it just hangs there. There is no motion. So this force F is equals to the weight. This force F is equals to the weight. This is the one thing. Now again you can see if this is the loop of the wire, then there will be two surfaces. If I have this is the thin film. I can see this film from this side and also from this side. So there are two layers, two surfaces, one from front, one from back. So there are two layers of liquid. You need to remember this in mind whenever they are talking about film or thin film or liquid film. There are two layers of liquid, one in the front side, one in the back side. So tension is what surface tension is what T is equals to force per unit length. This is what we have learned. And if you can see, we can write it as force per unit length effective. Why length effective? Because for one surface, this is the length L, and for another surface, there is also a length L. So surface tension T is equals to F upon, let this length is L. So L effective will be 2L. Why 2L? 1L is for the front surface, 1L is for the back surface. So total length is 2L. Now you can place the values. T is equals to force is what? Force is what? This weight, that is 1.5 into 10 raised to the power minus 2 divided by 2, and length of the slider is what? 30 centimeter. 30 centimeter means 0.3 meter. You can solve it out. Decimal will get cancelled. 3 is 5. So T is equals to 5 by 2 into 10 raised to the power minus 2. You can again write T is equals to 2.5 into 10 raised to power minus 2 Newton per meter. This is what tension is. This is what tension in the surface tension of the film. I think it is clear. Moving further. This is your homework question. The question is same, but a few things have changed. Here the mass of the weight, the mass of the body is asked so that it can support, and surface tension is given. Surface tension is given, mass is asked. In the previous question, mass is given, or you can say weight is given, and surface tension was asked. So it's identical question. Try to solve it out. Okay. Now, the next concept is surface energy. So it's time up actually. So we will discuss this in the next class. This is the next topic. So right now, this is your homework.